Hello, everybody. My name's Liz Bowles. I'm the Chief Exec of the Farm Carbon Toolkit in the UK. And I'm delighted to be here today to talk to you about some really practical aspects of greenhouse gas accounting on farm. And I've got a few slides to help me. So I'll just share my screen now. I'm hoping you can see that. I think you can. Okay, so I've entitled this talk Getting to Grips with Carbon in Agriculture, because I know that for many farm businesses, it's really complicated. I should say I'm a farmer myself in the UK, so I've also have to deal with the same kind of issues. So firstly, I'd like to introduce you to some of my team. The Farm Carbon Toolkit was set up around 12 years ago for farmers and by farmers. So we're very much rooted in the soil and rooted in agriculture. And within the overall organisation, we focus on supporting farmers where they are to understand their greenhouse gas emissions, how to reduce them, and how to remove more carbon into soils and into non-crop biomass. And I'll talk later about just the unique position that farmers are in through having that ability to store carbon, to remove carbon. And alongside our advisors, we are also one of the earliest organisations to create a farm carbon calculator for farmers to use to estimate their greenhouse gas emissions and indeed their carbon removals. Our calculator is free for farmers to use. You could go on now onto our website, find our calculator and set yourselves up and start a footprint within 5 minutes. And our calculator is slightly different to some other calculators in that we also enable farmers not only to measure their emissions, but also to estimate their carbon sequestrations into soils and non-crop biomass. So that makes us quite unique, really. So that's who we are. What I want to do now is just talk a little bit about climate change and agriculture and really what's going on. And I'm putting this slide up. My apologies, because this is what the situation's like now in Europe. It's become so busy with so many pressures coming on farmers to decarbonize, i.e. to reduce their emissions, and coming from so many directions. I'm not sure what the situation is in Pakistan, but certainly I would imagine that if the pressure's not being felt now, it will be soon, because this is probably, well, it is the largest challenge facing mankind, climate change. And although farmers have a massive role to play, they're not the only group that has to deal. We all have to deal with reducing our emissions. And this is why, and you can see here the changes to global climate and weather events. And all this information is coming from research. And what I've done is I've listed global heat waves, global cold events, global heavy rain, global drought, and global tropical storms, and looked at how things are changing in terms of intensity or frequency. And you can see that even now, we are seeing massive increases in global heat waves, global heavy rain, global drought. Global cold events are going down and will continue to go down as our base temperature rises. And the conclusion is that these are all linked to climate change, although there's some inconclusivity about global tropical storms. But then what's expected is more of this. And this is really significant, and especially for agriculture, because agriculture produces food that we all need to survive. And I'm just now put up some of those areas that is already, the impact of climate change is already being felt in these areas: crop development and growth, crop productivity. And in the UK, we're seeing that now quite significantly, with reductions in yields, reductions in the kind of crops that we can grow. And literally just last week, a third of parts of the country were covered in water to the depth of a foot, which meant those crops in those fields will have to be replanted when conditions allow, and that will reduce overall yields. And it's the same across the world. We're also having to think about what crops we grow, because the kind of crops that we've grown in the past can no longer tolerate the changing conditions. And also, as farmers, we have to think about what's changing in terms of the types of weeds, pests, and diseases that we have to deal with, and dealing with them in a way that doesn't increase emissions. And overlying all of that is degradation of the resource base we rely on. And by that, I mean our soils, our waters, and the air that we breathe. And all of these things have to be addressed at once, alongside restoring nature, because that's a sort of an element that sometimes we forget about, but it's absolutely critical that we do these things in tandem. Now, I just want to focus in on agriculture. And again, my apologies, this is perhaps a UK-centric pie chart. It's looking at the different greenhouse gases coming from agriculture, because it's slightly different than the overall greenhouse gas picture. Generally, we talk about carbon dioxide as being the main greenhouse gas emanating from our reliance on fossil fuels. But for agriculture, the biggest sources of greenhouse gases are actually methane and nitrous oxide, much more so than carbon dioxide. But it's also worth noting that nitrous oxide is many-fold times more potent than carbon dioxide and stays in the atmosphere for over 120 years. So it's a very significant greenhouse gas, and I'll talk more about that in a minute. And equally, methane is some 25 times more potent than carbon dioxide. However, carbon dioxide will stay in the atmosphere for about a century, whereas methane will generally only stay within the atmosphere for 12 years, which makes it a slightly different greenhouse gas to think about in terms of how we manage it, indeed how we account for it. But nonetheless, it's a very potent greenhouse gas, and I think it's worth making it very clear that for everybody, the need to reduce greenhouse gas emissions is present. And I think the good news for farmers is that managing your emissions and business efficiency are closely linked. So the more you can do to reduce emissions and store carbon in soils, the chances are your business will be more resilient, potentially more productive and more profitable. So there's definitely a win-win-win here. And agriculture is complicated because we rely on biological systems to produce food. It is the most complicated sector to look at decarbonisation in. And because it's linked to food production, it is difficult to measure. And also, it's really important to say that it does depend on the weather. And in some years, you might do exactly the same thing as in another year, but your emissions will be different because of the effect of weather in that particular year. So those are the greenhouse gases that we have to worry about within agriculture. In the next slide here, what I've done is I've split them so you can see the difference between emission sources for arable farms and for ruminant livestock farms. And for ruminant livestock farms, I'm talking about cattle and sheep, not pigs and poultry, because they're not ruminants and they don't produce methane as part of their digestive processes. So if we look at the arable farms first, by far the largest sources of emissions are coming from the production and use of chemical fertilizers, predominantly nitrogenous fertilizers. And remember what I said earlier, that nitrous oxide is far more potent than carbon dioxide. And it's very clear that we will have to either change the emissions associated with chemical fertilizers, or much better really, reduce our reliance on those products so that we can produce similar amounts of food but use far less nitrogen chemicals. And you can also see that quite a slug of it, the sort of brownish slug, is associated with fuel use, which is carbon dioxide, and then field operations. So that means all the cultivations that you do within fields. We know that they cause we know that they cause greenhouse gas emissions. So again, we're looking very hard at different ways of managing land tillage to reduce emissions. And you can see up here for arable farms, because I know you've been looking at crop protection, that the actual emissions associated with arable farming coming from pesticides is relatively low. Now, that's not to say that we shouldn't be looking to reduce our reliance, because we increasingly know that those chemicals are having a massive impact on biodiversity on farms. And increasingly, we know that we rely on that biodiversity to help us produce crops. Now, if we look at ruminant livestock farms on the other side of the graph, you can see that 50% of total emissions are coming from methane from the actual animals themselves. And then another probably 20% coming from how we manage their manures. But also quite a significant proportion coming from, I'm calling it imported feedstuffs. What I mean from a UK point of view is imported protein for livestock feeds that's generally coming from parts of the world where deforestation is taking place to grow those crops. And it's that deforestation that's causing the much higher level of emissions associated with those feeds. But again, increasingly, we're looking at how to reduce our reliance on products which could be consumed directly by humans, and trying to reduce their usage as animal feeds wherever possible. So that's kind of giving you a bit of a background. Now I want to talk a little bit about developments in farm carbon footprinting, because it is relatively new. If 5 years ago, very few farmers would have been doing it. Increasingly now in the UK, it's something that farmers are being required to. And I guess the first question is, why bother? And increasingly, it does make business sense, because it does enable you to focus on reducing use of expensive inputs and reducing emissions at the same time. And by understanding where your sources of emissions are, you can start to make decisions about what you're going to do. And for some businesses who are doing really well, and indeed for all businesses who are on that journey of reduction, it enables them to have a positive story about what they're doing. And actually, I think there's a real benefit for mental health of farmers to know that what they're doing is actually reducing their impacts on the planet. And it certainly will be future-proofing their business for future climate change, because generally making the changes that will be necessary will also be about adaptation to climate change and reducing reliance on really increasingly volatile priced inputs. So that's why you do it. And this next slide, it may look a bit busy, and I won't dwell on it long, but it's just to say this, that within agriculture, the actual emissions on the farm are really, those are what we call scope 1 emissions, but we also have to look outside that at scope 2 and scope 3 emissions. And that's why for businesses that buy from farmers, they're trying to add together the emissions all along the chain to the consumer. And it is complicated, but what at Farm Carbon Toolkit we do is we deal with these complexities, and we provide a calculator that allows farmers to report their emissions and removals to the farm gate. And we allow for estimation of scope 1, scope 2, and scope 3 emissions. So what I wanted to do for a little moment then is to focus on the uniqueness of agriculture. In terms of the emissions from agriculture, it's a pretty leaky system. And I've already mentioned this, that the emissions from agriculture arise as a result of producing food, and they're also dependent on the weather. And there is no one answer. Every farm is different. So it does need to start from understanding what your baseline emissions are, where they're coming from, and then think about what you can do about it. And it's important to consider pollution swapping. And by that, I mean, it's not much good if you get rid of one area of pollution only to have higher level of emission in another area. So we have to be able to look across the whole system. And in this case, we're talking about the farm system. And it is difficult to measure. And right now, there are many ways to calculate a farm footprint wrongly, but there is no one way to do it accurately. So, and the science is evolving daily. But I mentioned before, there are benefits. It's a real win-win-win for everybody, including the farmer, to look at reducing emissions. And biological systems are complex. And as I mentioned earlier, primarily we're focusing on emissions associated with methane, i.e. carbon, and from nitrogen cycles. But agriculture is unique in that it's both a source of emissions and a sink, i.e. we can remove emissions into soil and non-crop biomass. And that's also why the increasing focus on agriculture and farmland, because you have to have access to land to be able to use land as a sink. And alongside thinking of land just as a commodity, that landscape functionality in terms of how all the different elements of the landscape fit together also helps to improve resilience. And we need to think about that too. So carbon accounting, what is it? Effectively, it's simply identifying the footprint of a business. And it is the vital first step to enable you to quantify the contribution that your business is making to climate change. And I've already mentioned this, but the carbon footprint will identify the quantities and sources of carbon dioxide, methane, and nitrous oxide emitted from your farm. And it highlights areas where improvements can be made to reduce those emissions. But it also highlights, or at least our calculator highlights, where sequestration is taking place and looks at future options. So this slide is specifically devoted to our calculator, the Farm Carbon Calculator. And again, you can go and find it. If you literally just Google on Farm Carbon Toolkit, you'll find us. I've already mentioned it was developed for farmers by farmers. It's free to use. It accounts for soil carbon sequestration. And it allows you as a business to decide the period that you want to monitor your footprint over. And this balance you're looking at on the right-hand side of the screen shows emissions in light blue coming from all the different sources of all the different greenhouse gases at scopes 1, 2, and 3. It also shows you the level of sequestration and then the balance, which effectively means taking one from the other. So you can see in this case, this business is actually storing more carbon than it's emitting. That's getting less unusual, but it's quite unusual. And this is simply taken directly from our website. So I'm putting this slide up. I'm not going to dwell on it for very long, because I think sometimes we're in danger of having carbon tunnel vision. And climate change is an existential crisis for humanity, but carbon is only one aspect of food and farming, food sustainability. And I've just linked here all the ways in which all these things are linked together. And that's why it's so complicated for farm businesses, because they have to juggle all these different levers and imperatives. And you can see here down the right-hand side, biodiversity loss, drought, climate adaptation. These are all critical, as well as resource scarcity. And all these things contribute to the challenge of the farm businesses of reducing their emissions, removing carbon in order to get towards sort of a net zero situation. So the last couple of slides are very sort of straightforward, and just what can farmers do? So there's a few watchwords here that hopefully will be helpful. So firstly, sort of overall key actions to think about as a farm business. Certainly, yes, increased tree planting. In 10 years after you've planted them, they'll really start to store carbon. But not only that, they reduce the soil's vulnerability to both drought and flood. And they also have the ability to provide shelter for livestock, and increasingly shelter is a significant issue. We need to encourage low carbon farming practices, and I'll talk about those in a minute. Critical, certainly in the UK, is restoring our peatlands. I'm not sure, I'm afraid, for Pakistan whether you have peatlands, but in the UK, there's massive source of emissions at the moment because we're not managing them properly. And yes, certainly growing bioenergy crops to replace fossil fuels will be helpful. Critical to reduce food waste. I'm not sure the level of food waste in Pakistan, but certainly that in Europe is critical, as well as looking at reducing our consumption of energy intensive foods. And then some of these helpful farming practices, most of these I would say are low carbon farming practices. Planting cover crops and keeping soils covered at all times is critical. It really does reduce emissions. Changing the crop rotation to support greater soil health is really helpful. Changing how you cultivate soils and pulling less metal through soils is critical. Looking at what crops you grow, that's as much an adaptation thing as a mitigation. Looking at integrated pest management, so not reaching for the chemicals, thinking about how else can we manage pest control or pest management, and thinking about so many of the insect life as actually being beneficial rather than being a problem. And for livestock, it's about changing grazing practice and growing much greater variety of forage crops, which have got much greater, with deeper rooting. All these things, we know they help. And then in terms of planning for the future, these really are the building blocks, any farm business. The emissions here on the left-hand side, I've literally just listed the sources of emissions. So yes, it's fuels, it's inputs, fertilizers, chemicals, feeds, it's materials, things like concrete, machinery, all these things. Crops themselves emit, livestock definitely emits, and waste, by which I mean generally manures and compost. They can be both a source of emission, but they're also a source of improving soil health. So then the task is to reduce those emissions source, both in terms of them as sources, but also how much of them there are. But then on the positive side, the sequestration that's possible on many farms is huge. And it's effectively coming from trees. In the UK, it's coming from hedges. It's coming from non-cropped areas, which have got good cover, and coming from storing, removing carbon into soils. And overall, that will lead to an improved carbon balance and improving the ability to remove carbon from the atmosphere. So just finally, I wanted to say thank you for listening to me, and I've put up here our contact details where you can either go to our website or get in touch with us to find out more about what we can do. Thank you very much. Bye-bye.